Welcome, Honors Algebra 2 students. This is page 4 of Factor Fest. And these problems, I think it's 55 through a whole bunch more. But you want to be looking and seeing, with this problem, they ask you to factor it, first factor as the difference of two squares. So if we're going to write this as squares, you would write this as x to the third squared minus 1, technically, squared. And now we have that. So the difference of squares, we know, is a squared minus b squared produces a minus b, a plus b. So our a value is going to be x to the third. That's going to be our a value. So we'd have to write it in those two spots. And our b value is going to be 1. So if we write this, we're going to write our a value, x to the third, minus our b value, which is 1, and then x to the third plus 1. So we're just plugging into that template. And then we notice that we have the difference of two cubes and the sum of two cubes. And we have templates for that, where we know that the difference of cubes is going to be a minus b, a squared plus ab plus b squared. And then our sum of cubes is going to be a plus b times the quantity a squared minus ab plus b squared. So we're going to use those two templates. We don't have to rewrite this. Well, you can. So we see what our a is here. We can write that as that. And we know that and that. So in case we wanted to see what our a's and b's are, not so much. And this is my A, this is my A in this one, this is my B, and this is my B in that one. So if we write this, we're going to write this as x minus 1 quantity x squared. AB is it's going to be plus x, and it's going to be plus 1. And that's for this difference of cubes, and then the sum of cubes is going to be x plus 1, and it's going to be x squared plus x plus 1. Oh, sorry, that's not correct. That's going to be minus. It has to be the opposite of it. It's the minus part right there. That's an A. So that would be our answer, factored completely out using the difference of squares, and then factor further by the sum of two cubes and the difference of two cubes. So that's how we factored that one. In 56, it tells us to factor as the difference of two cubes. So now we have to write them as cubes. So we would write it like this, and then we would use our difference of two cubes template, which is a minus b, a squared plus ab plus b squared, knowing that our a value is going to be a squared, is going to be x squared, and so we're going to plug it into all of our a's, and our b value is going to be 1, so we plug it in wherever we see our b values. So that's going to be x squared minus 1 quantity x to the fourth plus x squared plus 1, and that is going to be, let's see, we're good there, and we see that this is the difference of squares. So that's x minus 1, x plus 1, and this was a crazy one on how to factor this. Whew. All right, so we're going to do some interesting terms. I had to look up that. That was a very peculiar way. So we're going to fill in some values. We're going to make this x to the third. Maybe I should do the ones that we fill in. I'm going to fill in that value, and then I'm going to write this value. So these are still here. So those are those values. And then I'm going to fill in a negative x to the third, a minus x squared, and a minus x. And now I have to, then I will do my plus x squared. So I guess this was, let's see if I'm doing this. Yes. So that's okay. And now I'm going to actually add a x squared, which will be the opposite of that. I'm going to have my plus x, and I'm going to have my plus 1. There we go. Whew. So we see that these three values are 1, 2, 3, and then we see that the x to the third and negative x to the third, so they cancel each other out. We see we have a negative x squared and a positive x squared, so they cancel out, and we have a negative x and positive x. So all of these cancel out, and if we simplified it, we'd get this starting equation again. Now, why did I write all these additional values? Well, I did that because I'm going to now factor by grouping. And how are you supposed to see that? I don't know how you were supposed to see that, but this is how we would factor this. And we group that. We're going to group these three, and we're going to group these three. So if we group all of them, let's go back. We have x minus 1, x plus 1, and then what is the common factor of that? Is if we factor out an x squared, and that leaves us with x squared plus x plus 1 from the purple group. That's from the purple. Now we take the blue group, and we can factor out a negative x. And if we factor out a negative x, we get x squared plus x plus 1. That's from the blue. And if we look at the red, we can factor out a 1. I love that. That technique is always fun when you factor out a 1, and you get x squared plus x plus 1. And what do we notice with each of those is that it has a common product of everything. So we notice that each of these are the same. So we can factor that out by grouping. So we still have our x minus 1, x plus 1. Let's pull out that common factor of x squared plus x plus 1. And what does that leave us with? That leaves us with x squared minus x plus 1. If we pull that factor out, so you get x squared minus x plus 1, and that looks like the answer on problem number 55. So pretty cool way, neat, technical. I think the hardest part is understanding how to make that grouping and knowing what to cancel and create. So that was definitely a tool belt. So put that in your tool belt, and we see that. Compare your answers in problems 55 and 56. Based on these results, what is the factorization of x to the fourth, x squared plus 1? Well, it's going to be x squared plus x plus 1 and x squared minus x plus 1. So that's what it would break down to after all this stuff right here, the purple, blue, and red. But that factored, we saw that factored to those two terms. So that's good. The polynomial blah blah cannot be factored using the above methods. However, there is a technique that allows you to factor it. This technique is demonstrated. This was pretty cool. So I like that. That was pretty nifty. So you inserted some values. I thought that was really neat because you added, or you introduced, I like the word introduce, you introduced these two terms for this value. And you just rewrote it. And very much like a times c, when we take the 3 terms and we write it as 4 terms in order to factor by grouping. But this was creative. So you created a binomial square here. So that binomial square is right here, and that produces that. So that was kind of cool. And then now you have the difference of squares. So you can create that. So it's neat. It's a very creative way, and we're going to have to use it a couple other times in these worksheets. So nice, sort of like completing the square on the same side. Yeah, we completed the square. Very good. Compare your answer in problem 57 with the final line in problem 58. Write a small paragraph describing what you notice. I would say you notice that you're completing the square. What value are you missing in order to complete the square? Because this is close to completing the square. This left side is close to completing the square. In order for it to be a binomial square, what does that need to be? Well, if we have x to the 4th and positive 1, what is that? Well, the square root, right? It's 2ab is always going to be, so it has to be 2. A is the square root of my first, so x squared. And then b, the square root of 1 is 1, so it needed to be 2x squared. So if we already have an x squared, if we only have 1, so we need to introduce another one. And if we introduce another one here, in order to keep it balanced, we also have to do its opposite. So that's how we're kind of completing the square there. And this was advantageous because we used that extra piece that we introduced as the difference of squares. So pretty cool. I don't know if you can write that as a small paragraph, but that's what is definitely happening. Factor using the technique outlined. So we would do, you take, and what do we need this middle term to be? Well, we need it to be 2x to the 4th. And we only have 1, so we're going to introduce, we're going to add an x to the 4th to this. So we'll add an x to the 4th in order to get this. And then we can't just add things to an expression. We have to have something minus it. So since we're introducing this value, we also have to balance it by writing its negative. So we get back to the original problem. So this now becomes x to the 8th plus 2x to the 4th plus 1 minus x to the 4th. And we like this because this is a binomial square. And so now this can be written as x to the 4th plus 1 quantity squared minus x to the 4th. And now we can do the difference of squares. So we could write this, and we can write this as x squared squared. So now we see our a and our b. This is my a value. This is my b value with the difference of squares. So we remember that a squared minus b squared equals a minus b, a plus b. So this is my a value, so that's going to be x to the 4th plus 1 minus x squared. And it's going to be my a value, x to the 4th plus 1 minus my b value, minus x squared. And we would write that in standard form. And we would write this in standard form. Oh, sorry, I made a boo-boo. That's plus. So they have to be opposite, sorry. If you caught that, good for you. Remember, it's got to be opposite. They have to be conjugates. So we got that. And then, as we see, we can again factor this. So that can be factored by using that same technique here. We're using the technique in 58. So this becomes x to the fourth plus 2x squared plus 1 minus x squared, because we introduced an x squared to make this from 1x squared to 2x squared. So, and this is a binomial square again. So that is going to be x squared plus 1 quantity squared minus x squared. Whew. And we can factor that. That is the difference of squares. So we have x squared plus 1 minus x. And we have x squared plus 1 plus x. Let's write those in standard form. And x squared plus x plus 1. So that is completely factored. We can't break that up because it's opposite. If we introduced another negative x squared, we'd have the positive x squared, and that wouldn't be the difference of squares. So we have that we pull down as the other piece. So this would be our completely factored work. That would be our answer. Yeah. X to the fourth minus x squared plus 1, and then x squared minus x plus 1. Yep. So that's a good one. That's didn't mean to do that. Let's delete that page. That's a good technical problem. Oh, that's it. That's all of that first page, apparently. Yeah, or page 4. Okay. That was relatively short. Good luck.